Hi everyone, welcome back. And in this section, we'll talk about numbers. We'll delve deeper into exploring numbers. Previously, we have seen two kinds of numbers, integer and floating number, which are the basic type of numbers. And in this section, we'll explore deeper. We'll look at different kinds of operation you can perform on numbers, and we will also explore the math module in the in Python. So let's go straight into exploring numbers in our Python code. I will open a new notebook which I will call I will name numbers. So previously you've seen us assigning integer value to variables. For example, you have num1 is equal to 10 and num2 is equal to, say, 10.2. So if you run this and you inspect the types of these two numbers, let's say type num1, type of num2, number 2. So if you inspect this, you can see that this num1 is an integer type and the number 2 is a floating type because it has values after the decimal point. So and this is good for Python because it takes the variable, automatically gets the type of the value that you store into it. Python interpreter automatically dictate the type of the variable based on the values that you store into it. If it's other programming languages, for example the C++ or Java, you will need to declare the type of variable explicitly before you start storing values into it. And if you have declared a variable integer, you cannot store string into it. But here I can change this num1 and say I am storing add it into it. If I run this and I inspect this again, it will tell me that num1 has changed to a string value. And if I change this value and I store 11.2 into it, I run this and I run this again, it will tell me that num1 has changed into float value. So Python interpreter automatically gets the type of variables as long as based on the value you store into it. And with this we can manipulate and operate on these variables with using math operators. So you have seen basic type of operator. For example, the addition operator. You have for example, we can say print num1 plus num2. So this is the addition operator, and it will just give us the addition of num1 and num2. We have in num2 10.2 and in num1 now 11.2, and the addition of both will give you 21.4. So there are other kinds of operator that you can use to operate on your numbers. So let's quickly write down this kind of operator that we have. So let's say maths operators. So you are used to some of them, the addition operator and the subtraction operator. You have the multiplication operator, and you have also the division operator. You can have this you are not used to, which is a exponential operator. This is exponential operator. You can say 2 exponential 3, so this is 2 raised to power 3, which gives you 8. So this is exponential operator. You can also have the integer division operator. Integer division operator, it truncates the decimal part. If you have for example, if you have 3 divided by 2, which should be 1.5, integer division operator will give you 1. It will truncate the decimal part. And lastly, we have the modulo operator. The modulo operator will give you the remainder of the division, the remainder of the division. So about the addition operator, you can say 6 plus 5, it gives you 11. So, and you also know about the subtraction operator. 6 minus 5 give you 1, and you can also relate with the multiplication operator. 6 multiplied by 5 will give you 30. So these are the basic one that you are used to in, and also the division operator. If you have the division operator, 6 divided by 5 should give you 1.2. Yeah, 1.2. So this is also division operator, which you have been used to. But the exponential operator, let's say you have 2 raised to power 3, so this is like 2 raised to power 3, which is 2 times 2 times 2, which will give you 8, I believe. So this is exponential operator. And also let's look at the integer division operator. If you have this, you know, in the normal division, 6 divided by 5 is 1 point. We got 1.2, but when it's integer division, if you use this, it will only take the integer part and truncate the decimal part. The result of this should give us 1, so it truncates the 0.2 part of this. That's integer division for you. And for modulo operator, gives us the remainder. So if you divide 6 modulo 5, if you divide 6 by 5, the 5 will go in one time and it will remain 1. So this also will give us 1. And if you have, like, let's say 8, if you divide 8 by 5, it will go one time and there will be remainder 3. So the value here will be 3. If you divide let's say 12 by 5, it will go 2 times and the remainder will be 2. So if you look at this, it will give you remainder 2. So that is how modulo operator works. So these are the different kind of operators that you can use to manipulate numbers in your program. Also, this operator, they have precedence. The operators have precedence, and we use mnemonics in to determine the precedence. And this is we call it paired. That's PEMDAS. So some say, please excuse my dear Auntie Sally. Please excuse my dear Auntie Sally. So this tells us how the operations, the order of operations. So the first one is the parentheses. So whatever you want to do first within your arithmetic expression can be put in parentheses. And the next one is exponentials. And we have next the multiplication, and next we have the division, the addition, and lastly the subtraction. So this is the order of operation. And if you have an arithmetic operation that contains all of this, let's say we have x is equal to 2 raised to power 3 plus 4, let's say, divided by 3, let's say, plus in bracket 6 minus 2. You know that this will be operated for 6 minus 2 will give you 4, then 4, and the next one will be 8. This is 2 raised to power 3, which is 8. Then you have 8 plus 3 divided by 8 plus 4 divided by 3 plus 4. Then the division will be done next, then the addition next. So if you run this now, and you have print x for us, you have the value of this expression 1.33, something around that. So the division by 3 gives us that floating value. So that's it. You have the precedence, you have the order of your operation. You can use that PEMDAS mnemonics to remember which one comes first. So One other thing I want us to discuss in terms of number is like in your program, if you're writing, for example, if you want to write game program now, you will want to include some kind of randomness in your game program. So we have the Python has provided for us a module that can give us that random numbers. So before we go on, what is module in Python program is likened to inbuilt classes in other programs like this C++ and Java. So Python is generous to offer us module. We call this module random, that actually creates random numbers for us in our programs if as we need it. And we have the core part of the Python language, which has things like the loops, the if statement, the math operator, and some other function, but some like print and input. So but every other thing that we might need to use in our program, they are contained in modules which is provided in Python. And if you want to use them, you need to import them. For example, we can say from random import randint. So we can import that, and this gives us a kind of integer random number. So you can say x is equal to randint between 1 to 10. So it picks up random integers between 1 to 10. Let's print it. Instead of assigning this to value, let's print the value. So anytime we print this, we'll be getting a random integer between 1 and 10. You can see we have 2 now. If you print it again, we have 6. If we print this again, we have 8. If we print this again, we have 1. This random number will be between 1 to 10. So this is inbuilt. This is given to us by randint inside random module of the Python. So sometimes you might need to actually install this if you don't have the module installed in your Python editor. So this randint provides to us, if you want to extend the random number from, let's say, from 1 to 20, so it picks any random number from 1 to 20 for us. So you can see now we can have 20, you can have 11, you can have 2, you can have 10. So it picks randomly from starting point you put here and the upper limit you have here. So also we have a module, we call it math module, which provide for us a math function that we can use from in Python. Let's say import maths. Let me import math first. So this is a math function, and let me check. This is a math module. Let's check the functions that we can use in that module. You can see it. There are lots of functions that you can use in this math module. So you can see different function, cosine function. So we will look at a few of the function, and you can actually look at the library where you can actually see how these functions work. So we have the Python documentation, this math Python documentation, which shows you different kind of functions you can use in this module. So you can read through this documentation and see how each of those functions work and use them. So here let me quickly look at let's use the ceil function. The ceil function, what does the ceil function do? Let's say from math, let me import the ceil function. Let me import also the square root function. Let me import also the pi. So these are functions in maths. Let's say we want to say print ceil 1.4. so what does it print? This will give us the value 2. So ceil, what does ceil does? What do they talk about ceil here? Let's go to the documentation and see what ceil. So math.ceil, return ceiling of x, the smallest integer greater than or equal to x. If x is not a float number, delegate. So this returns the smallest integer greater than or equal to x. So it returns the ceiling of x. So here our x is 1.4. So what's the smallest number that is greater than or equal to it? So smallest integer that is greater than or equal to it. So 2 is the smallest integer that is greater than or equal to it. So if you put 2 here, if the integer here is, if your x is 2, the value will also be 2, because this is the smallest integer that is greater than or equal to 2. But if you have 1.8, 1. Even 1.2 will give you 2, because this is the smallest integer that is greater than or equal to 1.2. So that's ceil. You can read about this. You can also use this let's say this square root function. The square root function, this will give you the value 2.0. If you put 9 here, this will give you the value 3. So this is the square root function. So the pi, let's print the pi. The pi will give you the value of pi, which is 3.14 to the precision level here. So you can say, for example, if you have a circle of radius 30, you can say the circumference is 2 pi r. You can just 2 multiply by pi, and the radius of your circle is, let's say, is 12. So the circumference 2 pi r is giving 75 point something like that. So, and assuming you want to have the area of that circle, which is pi r squared, so the pi multiplied by r multiplied by r squared. So this is r raised to power 2. So because exponential operator has a higher precedence, so we know that this pi r squared will be done first before multiply by pi. And if you want to be sure, you can just use parentheses. You know that if you put parentheses, this will be done first. So pi r squared. So this is the area of that particular circle. This is pi r squared. All right, so this is the area of the circle that has a radius of 12. Quick one about how to use math. You can explore further other functions that you can use in math that can be useful in your program. Let's do a kind of exercise with this. You have an idea about this quadratic equation, which says x for a quadratic equation given at like this, ax squared plus bx minus c. You have that value of x will be equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So this is a formula to find the value of x, the root of x, which will be 2 roots. So let's look at how we can write a code to get input value for a, b, and c, and it will calculate the root for us. Let's do that as an exercise here. So the equation says x is equal to minus b plus or minus square root of b squared minus 4ac, right? and all of this will be divided by 2 multiplied by a. So this is the formula. We will look at it one by one. We will take the input from user. We will ask for the A, B and C. For example, in this example, you know that we have, this is our A, this is our B, and this is our C. So we have A, B and C to be 5, to be 2, 5 and minus 3. So let's write the code that will automatically calculate the root of that equation for us. So let's take the A, B and C from user. User should get A, B and C from user, enter the value of A, B and C separated by comma. So you ask the user to separate that value by comma. So if a user wants to enter, he will enter A, B and C. Let's say our A in this equation that I showed you, our A is 2, our B is 5 and our C is minus 3. So the user will enter here 2, 5, minus 3 and press enter. So that's that we want from here, from there. So the next thing is that we want that value to be captured in ABC. You know, is assigned to ABC, and we want it to be splitted into a list. So you have seen another thing now. So this captures the value, ABC captures the value that user enter. Then this ABC string list will take the split. You know, the user have entered the value separated by comma. That's why we want it to be splitted using the comma. Let's look at this. Let's print what we have in this list. Let's print what we have in this list. If I run this, it will ask me for this number again. We have 2, we have 5, we have minus 3 separated by comma. If I enter this, it will print this value for us. You can see we have string 2, 5 and minus 3 inside the list ABC, because whatever the user entered there has been split into a list and converted to a list into ABC list. So this is still list of string. You can see this is the quotation around those numbers. That shows that they are still strings. Then I want to convert that list of string to a list of integer. So I have ABC list, integer list, ABC integer list. Now let me increase this. So I have ABC integer list. Here I have converted this list of strings to list of integers. So this takes in ABC integer list. So int num, every number that is in this, every value in this string list should be converted to integer and made to make another list. So let's look at what we have in this list now. If you print this, it will ask me for the numbers again. We have 2, 5, minus 3, and if I enter, you can see that the inverted comma, the quotation on those numbers, and is no more there. This is no more there because now the values, the element of this new list are integer. They are no more string like the elements here. So we have a list of integer. Now we have our A, B and C as integers inside this list. So we have our A, B and C as integer inside this list. I can just declare A is equal to this. You know that the first thing inside this list is A. So and the index is 0. And our B is equal to whatever is in the second here, which is 5, and the index is 1. And the last index here, C, is our C, which is the last one, and the index is 2. So I have assigned A, B, and C. So if I print my A now, B now, and C, you can see that I have my 2, 5, and minus 3. I have taken it from the list and assigned it to A, B, and C. So we have got our A, B, and C now. So the next thing that we want to do now is to compute our roots. First, let's have inside this square root. Let's look at what we have inside this square root. Let's look at the b squared now and the 4ac. The b squared and the 4ac. So let's say b square is equal to, we have b raised to power 2, right? And we have 4ac, which is 4 multiplied by a multiplied by c, right? So we have those two computed. We have this b squared done. Let's highlight it, and we have this 4ac done. So now we want to take 4ac away from b squared. So that's b squared minus 4ac. That's what is inside this square root. So let's call it in square root. In square root we have b squared minus 4ac. So we have this, right, minus this inside our square root. If you look at this square root now, we have this b squared minus 4ac. So we have been able to complete this arithmetic operation inside the square root. The arithmetic operation inside the square root is completed now. Yeah, so now we want to find the square root of that arithmetic operation. We have just done this, so let's find the square root. So now we will find the root of this. Let's call it square root. We have, we have imported the square root operator up here. Do we have it here? Yeah, we have imported the square root operator up here, so we can use it here. So we have found the square root of what is we have done here. So the square root has been carried out now. Then we have the numerator. So the numerator now is what we want to complete. The numerator will give us minus b plus whatever we get here, and also minus b minus whatever we get here. So we have two numerators here. Let's call this numerator 1. Numi 1 will be minus b, right, plus in square root whatever we have inside, as in out. Let me say, if we have in square roots here, let's say the out square root is equal to square root of in square root. So, and this will be minus b plus out square root, and this will be numi 2, which is equal to minus b minus out square root. So we have this done now. So the in square root calculate this, the out square root did the square root, then the first numerator did minus b plus the output of this, and the second one did minus b minus the output of this. So we have the two numerators over there. So and the numerator that we have in the calculation, we have 2a. That's what is under here. Numerator is equal to 2 multiplied by a. And now the answer. So we will have two roots here, and so let's say x1 is equal to numerator num1 over the num, and x2 is equal to num2 divided by the numerator. So we can print the outcome of our quadratic equation as x is equal to x1 or x2. So we can see how this works now. Let's bring all together. So we are not printing this anymore. So if I put everything here, so it takes the input from user 2, 5 and -3 and enters it, and this assign those value to ABC, and we use that ABC value to compute the root of x, which is 0.5 or -3. See, this is our ABC. So, and if you put the ABC inside this equation and you work it down, you get 0.5 and 3. And that is the brief illustration about numbers that I want us to look at in these sections. I've been able to show you some math functions. We have been able to see different kind of operators that you can use to manipulate your numbers, how these operators work. Next session we will be looking at another very important construct in Python programming, which is the if else statement. You see if else statements and ways that you can make decisions in your Python program. For now, we've explored numbers, and in the next session we will look at if else statements to make decisions in our Python program.